So hello students, in this video we are going to talk about a very important topics of thermodynamics. I can say a very fundamental topics of thermodynamics about irreversible and reversible processes. We define in the beginning of thermodynamics that on the basis of thermodynamic conditions in which change is occurring, thermodynamic processes are of four types: isothermal, in which temperature is constant; isobaric, in which pressure is constant; isochoric, in which volume is constant; and adiabatic, in which heat is constant, Q is constant. This is another classification of processes based on the path followed during the change. How the system reaches from initial state to final state. What path is followed. Based on that, we have two major type of thermodynamic processes. One is called irreversible, another is called reversible. So understanding of irreversible and reversible processes in thermodynamics, especially in chemistry, is very important. Otherwise, we may end up with wrong result, wrong calculation, where the quantity to be determined is not a state function, rather it depends on path followed during the change, like heat, work, all these are non-state functions. So if we don't know the path exactly, if we don't recognize the path exactly, if we don't consider the path followed during the change exactly, we'll end up with wrong result, incorrect information, and therefore understanding of these two type of processes are very important. So irreversible process first. So let us start with irreversible thermodynamic processes. So irreversible processes. To understand this irreversible process, let us consider expansion of a gas present in a piston. So suppose if we have a piston which contain some gas, say nitrogen gas, initially say at 10 atmosphere, and let us mark it as initial volume V1. Assume piston to be massless and frictionless. So if piston is at rest, indicates that we are also applying an external pressure of 10 atm in the beginning, and therefore pressure equilibrium is there and piston is at rest. Now suppose if we release the external pressure, if we decrease the external pressure to say 1 atmosphere, so now we have released P external to 1 atmosphere. What will happen? Piston will rise, gas will expand to a new volume V2, where P final is also 1 atmosphere. During the expansion, the pressure of gas changes from 10 to 1 atmosphere. But this expansion is occurring against a constant external pressure of 1 atmosphere. That is, the piston is doing work against a constant external pressure of 1 atmosphere. That is the condition of irreversible thermodynamic change, the change that occur against a constant external force, that occur against a constant external pressure. So the process that occur against a constant external force. Here pressure is irreversible. So that is the criteria for irreversible change. Then what is reversible? What is reversible process? Let us consider the same system in which gas is present initially at 10 atmosphere. Here is the initial volume V1. Now suppose if we, of course initially external pressure is also 10, so piston is at rest. Now suppose if we decrease the external pressure by infinitesimal amount dP, we decrease the external pressure by infinitesimal amount dP, so now we have pressure P minus dP. What will happen? Now the external pressure is slightly less than internal pressure, the gas will expand, but by infinitesimally small volume dV. Now if we again reduce the pressure by dP, the gas will again expand by a small volume dV, and if we continue this infinite times, we may reach we may reach to the final volume V2, where P external is 1 and P gas is also 1. This process has occurred not against a constant external pressure but against a variable external pressure. The external pressure is changing every time by dP, dP, dP. So the process that occur due to infinitesimal difference in internal and external condition is known as reversible process. So that is how we define irreversible and reversible process. Now we are going to compare some of the properties of these two types of processes one by one. So let us do the comparison. On the left side, let us write irreversible process. On the other side, reversible process. The first is, in irreversible process, piston stop only when the internal pressure becomes equal to external pressure. Before that, piston does not stop. But in case of reversible process, piston stop infinite times before the final state is reached. So we can say that it is a one-step process. Whereas reversible process is a infinite step process. In irreversible process, system attain equilibrium only at the final state of change. That is, system does not remain in equilibrium with the surrounding during the change. Whereas in reversible process, infinite number of intermediate equilibria are involved. Therefore, we can say that system is virtually always in equilibrium with the surrounding during the change. So, system does not remains in equilibrium with surrounding during the change. Here, system always remains. System always remains in equilibrium with the surrounding during the change. So infinite number of intermediate equilibria are involved. In irreversible process, there is a large difference in internal and external pressure. So slight change in external pressure, slight increase in external pressure at any instant of change cannot reverse the process. But reversible process can always be reversed at any point of time by slight change in external pressure, external condition. So can't be reversed by small change in condition. On the other hand, can always be reversed by infinitesimal change in condition. Very small change in condition can change the direction of process. Since irreversible process is a one-stop process, it completes quickly. Whereas reversible process involve infinite number of intermediate equilibria, so it takes infinite time to complete, that is, it never complete in practical time. So complete in finite length of time that can be measured. Never complete practically. Therefore, all practical processes are irreversible and reversible process is just an ideal process. So, all practical processes are irreversible. whereas a reversible process is an ideal process. It is an ideal process. Another very important quantity which differ in these two is the amount of work done. So let us do that separately. Work done. In irreversible process, work is done against a constant external pressure P. The parameter of system is changing every time. So it's very difficult to find out the work done by the system directly. So what we do, we determine the work done on the surrounding and then we change the sign of that to obtain the work done by the system, applying the principle of conservation of energy. So in that way we can say that W irreversible is equal to minus P external delta V. P external delta V is the work done on the surrounding. So minus P external delta V will be the work done by the system on the surrounding, and they will be same numerically since we are applying the principle of conservation of energy, assuming no any other changes occurring. But that cannot be done in reversible process. In reversible process, in reversible process, work done in one infinitesimal step can be written as dW is equal to minus PdV. And then we'll have to add up the work done in infinite steps, and that is done by integration of this work. So total work done will be integral of work done in one infinitesimal step, and that will be equal to integration of PdV from volume V1 to V2. That will give the work done. So these two quantity are different, and work is a non-state function, so it depends on path between same initial and final state. Work done will be different if process is done reversibly and irreversibly. So in case of isothermal process, in isothermal reversible process, this W can be written as integration minus integration of PdV, which is P is equal to nRT by V minus integration of nRT by V dV. Since system is closed, so N is constant. Process is isothermal, so T is constant, R is also constant. So it will be equal to minus nRT integration of dV upon V between limit V1 and V2. And integration of dx upon x is log natural x. So if we integrate and put the limit, it will be minus nRT ln of V2 upon V1, and that is the work done. That is the work done by the system in irreversible thermodynamic process. So we can see that at same temperature from same initial state, if gas is allowed to undergo expansion irreversibly and reversibly to same final volume, then work done will be different in the two cases. That can be seen graphically also. So let us see how they appear on the graph. Here we have a pressure volume graph. Let us mark here 10 and here 1 atm. Here is the initial volume and here is the final volume. In case of irreversible process, the work done is P external delta V, and P external in the present case I have taken 1 atmosphere. So it is 1 into delta V, 1 into V2 minus V1, and that is nothing but area of this rectangle. So this is minus W irreversible. So this is the work done in irreversible process. So gas was initially here, finally here. So if we want to describe a path, it will be like this. That is the irreversible path on a PV diagram. So this is for irreversible process. In case of a reversible process, what is happening? Once again, here we have 10 atmosphere, here we have 1 atmosphere, here we have initial volume, and here we have final volume. Gas was present initially at this point. What is being done? We are first decreasing pressure by a small amount and then allowing it to expand by a small volume dV. So work done in this small step will be the area of this rectangular bar, and that is dW. Again we are decreasing pressure and allowing gas to expand, and this process is continuing again and again. So work done will be determined by summing up all this rectangular area and all this area will determine the work done in reversible process. So if we connect all this point, this will appear like a Boyle's curve. Boyle's curve, and area under the curve will be the total work done from initial volume V1 to final volume V2, and that will give the integral of dW. Of course, this work done will be greater than the work done in irreversible process. Not only greater, it will be the maximum work done possible in expansion from V1 to V2. So that is how we correlate irreversible and reversible process, and understanding of processes are very important. Here we have taken isothermal case. The same can be taken for adiabatic process also. In adiabatic process, if we want to determine work done, we must know whether the adiabatic change is occurring reversibly or irreversibly, because the final temperature will be different if expansion occur adiabatically reversibly and adiabatically irreversibly, and accordingly work done will be different.